Hello everyone, my name is Mrunang Pawar and I am second year undergrad student at Srimati Kashibai Navle College of Engineering Pune. We are elated to bring to you yet another module of HTM Qubits, Quantum of Workshops packed together. This is our 19th session of the highly engaging HTM Qubits and we expect this one to surpass the awesome response we have been getting for the past 18 sessions. I hope you are the one who is excited to learn about Julia programming. So here is your chance to enter into this amazing world of Julia programming language and kickstart your journey. Today we have with us a talented, experienced, well-known personality, none other than Logan Kilpatrick. He is a software engineer at Apple and Julia language community manager. His experience in the field makes him more than qualified to introduce you to the Julia programming. Without taking any of your precious time, I would like to hand over this session to Logan so that he can deliver you a marvelous tour of Julia programming.
Thank you so much for the kind intro. I'll make my disclaimer that the views that are being represented today, and even how I'm representing myself, is as the Julia community manager. So that's who I'm here as. That's who I'm representing all of this information as. So I'm super excited, and again, this is a great opportunity for folks to hopefully learn about the Julia programming language, and then also hopefully we'll talk about some ways that folks can come in and actually contribute to the community, contribute to the ecosystem. So I think that will perhaps be the most interesting part. I tried to, when I was putting together this presentation, sort of stay away from at least some of the technical details around Julia. And the reason for that is just there's a ton of great resources out there. I sort of don't need to reiterate those for you, but hopefully I can provide this context around how folks can get involved, what Julia is, because I'm sure there's people who don't know that. So I have some slides, and perfect, wonderful. So let's dive in, and we'll look at what we're going to talk about. So we'll briefly go over what Julia is. I'll touch on my journey learning Julia, and then most of the presentation we'll talk about how folks can actually leverage Julia. And I apologize for the weird display of my slides. They're actually very fancy and interactive, and they have a bunch of moving animations and stuff like that. The problem is that my computer is never happy about running all the animations in the presentation while I'm presenting, so it becomes difficult. So this is the PDF version so that my computer doesn't explode. So if we're talking about what Julia is, and I think perhaps it makes a lot of sense to take a step back before we actually look at what Julia is and think about in the sort of the scope of programming and computer science. Why do we need another programming language? Sort of what are the challenges that people are facing, and how can we solve those challenges? And I think this is a really important question to ask yourself when you're going to learn a new tool. Like, do I really need to learn this new tool? And the reality is, for some folks, the answer might be no. There really isn't a reason that you need to go learn something. But I do think that there's a bunch of different segments of folks, whether you're a computational scientist and you're sort of at the limit using some of your existing tools, or you just want to contribute to something that's new and sort of being built right now. I think there's a bunch of different reasons you might want to contribute. But again, asking the question of why we need another programming language, I think is an important exercise to go through. So if we talk about why Julia specifically, why do we need another programming language, and why specifically do we need Julia sort of in this programming language ecosystem? There's a bunch of different reasons. Again, I think this sort of what I have up here on the screen scratches a few of those itches, potentially. I think some of the most important ones, speed and reproducibility. You don't get this in a lot of other programming languages, whether that's Python or R. Right out of the box with Julia, you have this incredible speed. And again, you have a reproducible environment that you can share your code with somebody, and they can just set it up and it'll be good to go. And there's really no worrying about all the dependencies and things like that, which is super important. The other piece, and this is something that, again, from evaluating a tool as sort of a technical solution to a problem, a growing community, probably isn't something that's part of that equation. But I think in general, again, if you're interested in sort of beyond the bounds of just using Julia as a tool to solve some specific problem, I think there's a ton of opportunities that have come about in the community recently, just because of how fast things are growing and how fast things are changing. So I think that's at least for students, it's a huge opportunity to get involved and contribute something super meaningful. So that's definitely a selling point, at least in my mind. And then the last sort of conglomeration of all of the benefits of Julia, what that results in is a shorter innovation cycle. And what that means, again, is, from when you have an idea in your head to when you actually can take that idea, translate it into code, and then have that code have a real impact in the world. That innovation cycle using Julia is significantly compressed because of the speed of the language, because of the reproducibility, because of the high-level syntax that allows anybody with a little bit of familiarity with programming to use the language and excel with it. And I'll also just put in my quick comment that if there's questions or thoughts on any of this stuff, happy to answer those thoughts and things like that. So feel free to put something in the chat, and I'll do my best to answer those questions. But feel free to stop me, and I'll answer those questions as we work through these slides. So at a really high level, the Julia programming language is open source. As we talked about before, it's reproducible. It has syntax that's very, very familiar. If you've programmed in Python or MATLAB before, it should be a relatively easy transition for folks who have used those languages. And again, if you haven't, it's the syntax is more or less similar to many, many other programming languages. So it shouldn't be a huge jump for anybody, regardless of your programming experience. The other thing that, again, separates Julia from a lot of these other programming languages is that from the ground up, the Julia language was built to be fast. And that's, again, fundamentally different than a lot of these other programming languages in that, I have this conversation with folks a lot of the time. You can write fast Python code. It's possible. Like there's no theoretical reason that your Python code can't be fast. But again, the challenge is the domains and the specific areas where you can write fast Python code are limited. And again, you have to write the code in a specific way. You have to do all these things, sort of go through these hurdles in order to get this end result, which is fast Python code. And I think, obviously, in the case of Julia, that's just not what ends up happening. You can sort of just write your code how you would normally want to write it, and it'll be fast right out of the box. Again, because of this intentional design, because of the JIT compilation that takes place. So it's, again, something to keep in mind as far as when you're trying to decide between what tool makes the most sense for you. This is something, at least that I always think about, the speed aspect of it. The other piece is that Julia, again, because of the speed and because of the intentional design, is super well suited for problems that have a large scale or are very data intensive. So if you, and we'll actually look at some of these use cases in a minute, but you'll see right away, the problems that Julia is being used to solve are not your everyday, like, let's, do some basic logic and check conditionals and toss a couple for loops in there. They're really, Julia's being used to solve some really intense, difficult problems. And again, the whole motivation for creating the language back when it was created in 2012 was, hey, we have this set of tools that currently exist. We have all these problems that are really difficult. And it just happened that the tools that were available sort of weren't lining up with the available or with the problems that had to be solved. So there was some thought, hey, maybe there's an opportunity here to build a better tool to solve these really difficult problems. And sort of the result of that was the Julia language. So if we're talking about some of these really important and impressive use cases, Puma's AI is always one of my favorite ones to talk about, just because it's so interesting. So there's a bunch of different use cases that Puma's sort of accomplishes, but it's basically this pharmaceutical simulation company / open source software that is being built to, one, create personalized medicine. We'll talk about what that means in a second. And then two, actually helping accelerate the discovery of drugs and vaccines and things like that. So both the teams at Pfizer and Moderna use Julia, use Pumas to actually help solve a lot of these, again, really difficult problems that they have to solve. On the personalized medicine front, this again is such an interesting use case. To me, it makes perfect sense. The fact that, we all go to the doctor and, if we have the similar symptoms and we're seeing the same doctor, the chances are they're going to give us like the exact same prescription for whatever the problem is that we're having with our body. And that's so interesting to me, just because, we all have different diets. We all have different levels of activity in our lifestyle. We're all, sleeping a different amount. We're all, doing all these different, our bodies are different fundamentally. They're the same in a lot of ways, but they're also different in a lot of ways. And to me, the idea that we go and get the same sort of treatment for a problem which could be completely different internally in our body just boggles my mind a little bit. And Pumas is sort of setting out one of the use cases that they're helping solve is this idea of personalized medicine. So you can go into your doctor, they can basically leverage the software to do a bunch of personalizations as far as like how much of a drug should you be getting and things like that. So super, super interesting use cases. Someone in the chat is saying, what are some real world applications and some places where Julia is already being used? So it's a great question. This is one of them. Pumas is one of them. The Pfizer team, the Moderna team are both using Julia. Julia was used, and I'll talk about this a little bit more later on when I go into sort of my journey using Julia, but there's a few teams at NASA that are using Julia, lots of academic research that's being done with Julia. So it's pretty widely across the board being used to solve a lot of these, again, really intense computational problems. So let's look at another use case and hopefully help answer the question of where Julia is being used and what some of the applications are. So this is another really cool one, just because I think, climate change is such a prevalent issue in conversations now, especially in the domain of computer science. And how can we leverage all these computational tools that we have to help solve this Earth scale problem, which is extremely difficult. And Klima is one of the potential solutions to the problem of climate change. And when I say a solution to the potential problem of climate change, what I mean is that one of the really difficult parts about climate change is actually understanding sort of what is actually happening in the environment, and what is actually, if we do something, what's that going to result in? Like, let's say, for example, we got rid of all of the cars on the roads and all of a sudden there was no more cars tomorrow. What's the impact on the environment? And you can sort of start to think, okay, you could sort of do some backhand calculations about, the dramatic reduction in CO2 emissions and stuff. But beyond that, like it's really difficult to understand what the actual impact would be. Would it actually have an effect on the, rising temperatures in the ocean and things like that? And again, the Klima project is basically set out to say, hey, can we build climate models that are actually, will scale up to the entire planet and provide an accurate way for us to sort of investigate some of these potential questions. And, when they were trying to sort of flesh out this idea, they landed on using Julia because of the scalability, because of the performance and all those things. And to my understanding, this project has been going quite well so far, and they're making a ton of progress. It's a bunch of open source code. It's based out of Caltech. So if this is something that's interesting to you, definitely check it out. There's a lot of really cool things happening in this regard with the Klima project. So hopefully the takeaway from all of this is that, Julia is perhaps worth trying. And maybe if I haven't convinced you so far, we've still got a little bit of time, so I'm not losing hope yet. But I think, again, to me, these sort of use cases are what get me most excited. I think seeing, what's happening in personalized medicine, seeing what's happening in, helping solve some of these climate change problems are again, for me, that's super motivational, and those are things that, you can see the direct impact of your work. So it's super exciting. But again, perhaps if I haven't convinced you, we'll talk about some other things, and perhaps that will sort of align with motivation for folks. So again, really briefly, before I talk about sort of ways that folks can contribute to Julia, I'll just say that, I started my Julia programming journey back when I was interning at NASA. And again, it was a super cool experience for me, and I had the chance to work on a project that was sort of really in the research and development phase at the time, and now it's sort of made the transition to being part of an actual NASA mission, which is super exciting. And I'm really glad that I got to have that experience, and a ton of really, really smart people at NASA working really, really hard to help make this happen. So very interesting, super cool use case. And again, there's tons of other places like this where folks are using Julia to help solve some of these really difficult problems. I think the problem we were trying to solve at NASA, extremely computationally intensive, really just a fundamentally difficult problem to solve. And again, the existing tools sort of wouldn't have done the job for us. We didn't have, 2, 3, 4 days to run a simulation and see what happens. We could use Julia and sort of scale that down to a few hours. So it makes a lot of sense to, again, sort of compress that innovation cycle as we talked about before. So again, hopefully maybe there are folks who at this point are like, okay, Julia seems interesting. Perhaps it's something worth learning. And one of the really great opportunities is that again, Julia sort of started has very deep roots at MIT, but there's also, again, that's sort of still going on today. There's a Julia lab at MIT, and there's also a bunch of folks who teach Julia classes at MIT. And they've done an incredibly good job of making those resources for their class available to the world. So, they're not just teaching MIT students, they're actually, teaching anyone who wants to learn Julia, which I think is super cool, very unique, and is sort of, if you think about it, the way that education in a lot of senses should be. Like, it's not, it shouldn't just be confounded to or constrained to the folks who are in Boston, attending MIT. The resources should be available to everyone. And again, those folks at MIT have sort of embodied that and made the course available to anyone. So if you go to computationalthinking.mit.edu or just type in computational thinking Julia on your favorite search engine, you'll find the course. And again, the lectures, the materials, the homework sets are all available online for free. And there's also, a Discord channel, so you can go talk to the professors if you want. It's again, really cool opportunity to learn Julia with other folks who have the same sort of desire and passion as you do. So, question in the chat about prerequisite knowledge required before trying to learn Julia. So that's a really good question. It sort of depends on what you want to do using Julia. I would say it's like any programming language, where obviously if you know another programming language, it just makes it easier to pick up. It's a little bit more of a smooth ride if you already know how to program. But I will say that there are enough resources where if you don't know any programming languages and you want to learn Julia, you should be able to do so. If you go to the Julia Languages YouTube channel, there's a introduction to programming in Julia for nervous beginners. So for folks who perhaps, have maybe tried to program before in the past, it didn't work out for whatever reason, or you just, maybe this is your first attempt to learn how to program. We have those resources, and I think, you're more than welcome to take advantage of them. And again, if you have experience with another programming language, picking up the syntax, all the ideas are pretty much the same. So it shouldn't be too much of a hurdle to jump over. Yeah, it's a great question though. So sort of moving to the conversation of how folks can get involved in the language. I think, again, there's two things that get me really excited. I think all the places and the use cases for Julia are awesome. That is, fundamentally one of the really things one of the big things that gets me excited. But I think the other thing that gets me excited is how many opportunities there are to get involved and to make a super meaningful contribution to the community, to open source, to the ecosystem. Again, that's something that gets me totally jazzed. I love the opportunity to go and contribute something that's going to have an actual impact in the long run. And I think doing stuff in the Julia domain is, again, this is such a unique time because the language doesn't have the same scale as something like Python would. So you can make a contribution and people will actually read what you have to say. They'll look at your questions and things like that, which again, I think is awesome and a great opportunity for folks. So what some of these different opportunities are, and this is super broad and high level, but you sort of have these 3 different options as far as how you can contribute. You have sort of the more traditional open source contribution, which is, I'm going to go, find your code base that's in Julia, make a pull request, fix a bug, add a feature, whatever that might be. So that's definitely a super viable opportunity to contribute. Another possible code contribution, if let's say perhaps there's a package you use in Python or R or MATLAB or something, and you want to try building the analog version or the sort of parallel version in Julia, that's another big opportunity. I think that's where a lot of folks sort of do their first Julia package is, take some tool that I was using in Python, convert it, make a Julia version, and then you sort of, again, have made this huge contribution to the Julia community, and you've helped make it easier for other folks to transition to the new language, because now, again, they have the same tools that they were using in Python, but they have those available in Julia now, which is super awesome. The other thing, and this is perhaps one of the more common ways now that folks make their first steps into contributing to a new programming language or any open source project, is just via a documentation contribution. So these are actually, doing a pure code technical contribution is always fun. It's always a good time. It's always super impactful. But I'm actually always looking for opportunities for myself, at least, where I can make a really impactful documentation contribution. And sort of usually the way that this ends up shaking out is I just go and read what people have written. I, go to a packages documentation. I go to the core Julia code-based documentation, and I just read it. And I sit there for 20 minutes, 30 minutes, and I say, does this make sense to me? And if it doesn't make sense to me, I, spend a little bit more time, try to understand, figure out, what's actually happening. If it still doesn't make sense after that, go and open an issue, tell them what you've done, go through the process of what you think they're trying to say, and try to see if that is aligning with what someone is actually trying to say. And if it's not, then again, that's a great opportunity for you to help make that documentation better. And this is, again, one of the most important things. If you are having trouble with it, someone else is as well. Like that's just the reality of programming and open source and everything. So I'm always reading as much as I can as far as other people's documentation, their tutorials, all those sort of things, to make sure that they're all fully fleshed out, they make sense. And when they don't make sense, going and making that contribution. Again, that's such an impactful contribution to the community. I think those are some of the most underrated and most important contributions that someone can make to an open source project. And then the third possible way of making a contribution sort of is a blanket for a ton of different areas where you can contribute. I put non-technical. It's actually, sort of, it might just not be, when I say non-technical, I usually mean a contribution that doesn't result in GitHub contribution activity, for the most part, is what I mean by non-technical. When I say non-technical, I mean like writing a blog post, doing something like that, speaking at an event and sharing, about the Julia. Like, I think what I'm doing right now is a quote unquote non-technical contribution to the ecosystem, sort of just sharing what Julia is, how folks can get involved. And those, again, I think And I might be biased because I spent a lot of time doing sort of non-technical contributions. But I think, again, these are super important as well, just because you sort of need to get the language and things like that in front of folks so that they know what it is and know what some of these resources are, know how they can contribute and get involved. So I think this is, again, such an important opportunity. And when I sort of look at all these different contribution pathways, there's a lot of time a sort of barrier for some of these other contribution pathways. Like if you want to contribute code, the reality is the code has to be good enough that the maintainers of the open source repository are going to say, yes, we want that code in this code base and we're going to use it. And same thing with the documentation. I think for non-technical contributions, again, the cool part is that you don't need anyone's permission to do that. You can go and make a video online about how to do whatever in Julia, and that's a non-technical contribution, and it's a super important contribution. And again, no one can tell you that you can't do that, which is something that I love. I love the permissionless ability to just go and make that contribution. I think that's super cool. So something to keep in mind when you're sort of perhaps looking at something like this and saying, okay, well, I see all these different options. How can I go make my contribution? For a lot of folks, it sort of flows from the right-hand side of the screen to the left, where you start off with these non-technical contributions, make some videos, perhaps write a blog post, something like that. Just talk about it with your friends, and then go and make a documentation contribution, and then perhaps code as well. And I don't think that this framework is sort of exclusive to programming in Julia or the Julia ecosystem. I think this will apply to any open source project. So again, if Julia doesn't end up being the tool for you and doesn't end up being what you're super interested in, I think again, you can apply this same framework to whatever the ecosystem is that you're part of. So if we dive in a little bit deeper as far as where places are for students to sort of benefit from open source. And I think this, again, is one of my favorite things to talk about, just because it's so apparent, and it's also something that I wish that I sort of, when I was still a student, or I still am a student, but when I was, in my first 4 years of undergrad, if I had this understanding, I think it would have helped me a lot. And these are some quotes on the screen for what employers are looking for in students when they're hiring them on as first-time software engineers or whatever it might be in a technical domain. And some of the things are, self-motivated and excited about technology, offering a fresh perspective, real-world experience outside the classroom learning. And I think all of these three things, you can get those experiences contributing to an open source project. I think specifically Julia is a prime candidate for this, but again, I don't think it's constrained to just Julia. I think there's a ton of really great open source projects that you can contribute to. So, keeping this in the back of your mind as far as, you don't need, a bunch of killer internships in order to get your first job. That's just the reality. You don't need to do that. You can go and contribute to an open source project. You don't have to apply. You don't have to, no one has to tell you they want you to contribute. You can just go and do it. And again, that's what I love so much about open source. It doesn't matter where you went to school. It doesn't matter what your GPA is. You can just go in there and make a contribution that's impactful. And then, on the flip side of that, you now have this public track record, with the people who you've worked with now vouch for you, and you again have this public track record of contributions that are impactful and meaningful. And when you go into a job interview, you can now say, hey, you know what, I have, I don't need to just talk about the things that I've done. You can go to my GitHub profile and you can actually go and look through some of these contributions. You can look through the packages that I've written. You can look through the projects that I've contributed to. So it's a super important thing that I think students can really leverage to help them get a job. One of the questions in the chat is it also being used in Tesla cars? Because it sounds like Julia is something that would be used. This is a really great question. I think my understanding is Tesla is using very much traditional resources as far as doing their machine learning stuff. I think Julia would be a prime candidate for being part of the ecosystem that they have, with computer vision and things like that. So I don't think that they're using Julia right now, at least for their computer vision / self-driving stuff. But I think, again, it would be, in my opinion at least, it would be the right tool for the job. I think I've seen a few Elon Musk tweets about the tools that Tesla uses for machine learning, and I don't believe that Julia is part of that stack right now. But that's a great question, and give Elon Musk a tweet and let him know that that you think Julia would be the right tool, and we'll see what he has to say. So again, at a super high level, as far as why students should help contribute to open source, you have and this again is, there's so many cool things. You have the opportunity to really get involved in a community of folks. And what I appreciate a lot about open source is, for the most part, people are there because they're excited about it. Most, probably 99% of people making open source contributions aren't being fiscally compensated in any way. There's no monetary kickback for them. They're doing it because they enjoy it. And I think that's really special. And you have, there's a lot of really cool implications of that. There's some downsides as well, but generally you have people who are really passionate about something and they want to spend their time doing it. So getting involved with those folks, I think, sort of has an outsized impact on your sort of journey in your career and things like that. So definitely something to keep in mind. Also, again, contributing is going to help in your career. More and more job applications, at least ones that I've seen, are looking for specific evidence of programming experience. And I remember, I'll go back to an experience I had when I was interviewing for a role at Shopify. They actually asked me to link a specific project that I'd made on GitHub, and during the interview, we actually went through my code and talked about it. And they were like, okay, so why did you do this? What was the reasoning behind approaching things in this way and such? So that was a really interesting experience. And again, because I'd made these open source contributions and created packages and things like that, I had this substance to talk about in the interview. And also, again, it being Julia, sort of going back to the slide before when we were talking about why students should get involved in open source projects. When you get hired for your first job, the reality is that you're not being hired because you are the best programmer in the world. You're not being hired because you have the most knowledge about how to solve these sort of specific problems in the world. The reality is you're being hired because you're bringing a fresh perspective. You know about the cutting edge tools. You know what all the new things are. And the company can hire you, bring you in, and you can share that knowledge with them. And again, I think Julia is such a great opportunity to literally embody that, learn something really new that's cutting edge and is growing extensively, and then go and share that with other folks. And I think in my Shopify interview, it was an interesting experience because the folks who were interviewing me actually didn't have any Julia experience. So not only did I sort of get to go through and show them my code and talk through it all, but I also got to sort of talk at a really high level about, okay, what is Julia? Why did I choose to use it for this project? And I think it sort of, I didn't end up getting that job, but I think at least in hindsight, I see there was probably an advantage for me in the specific case because I got to show my understanding of things beyond the normal sort of scope of just, writing a little bit of code with some logic and things like that. I got to sort of show a little bit more sort of dynamic thinking around, the tools and things like that. So again, I think it was a super positive impact for me in that experience. And the same thing would extend to folks who are going through that process as well. So that's what I have as far as sort of this high level material as an introduction to Julia. If there's questions as far as how folks can get involved or things like that, I'm happy to take those now. If there's, again, perhaps there's more specific lower level questions about programming in the language or things like that, or how folks can get involved, happy to take those. The other thing that I'll call out is that the annual Julia conference is coming up in July. I think this is such an awesome opportunity to get a sense of the community and of what Julia is being used for. So we're going to have something like 300 sessions from folks all over the world in different industries and spaces talking about some of the things they're doing with Julia and all the cutting edge tools that they're building and such. And again, there'll also be a bunch of really cool community opportunities where we're going to have 300 people in a gather town session and getting to chat with folks and things like that. So really exciting. I think it'll be a great time. And again, if folks are interested, you can go to juliacon.org and sign up and share a little bit. So one of the questions coming through in the chat is a little off topic. Could you share about your experience applying 503 times for an internship at Apple? Yeah, so that is a great question. Sort of going back to that experience, I was my first 2 years of undergraduate studies. I actually went to community college in California, and while I was at community college, I worked part-time at the Apple store. So I was a specialist, I was a technical specialist, I was a technical expert, all part-time, all helping folks who were having problems with their devices when they came into the store and going through that experience. So really great experience, loved it. It was awesome, learned a ton. But all the while I was working at the Apple store, sort of my goal was, I wanted to transition from the retail store into a corporate environment. So I basically, over the course of 2.5 years, ended up applying 503 times for a bunch of different internships, jobs, things like that. I interviewed a bunch of times. I probably had, 30 interviews maybe over the course of that 2.5 years for different roles at Apple and different internships and things like that, while also applying for things that, I interned at NASA during that time. So I was applying for NASA internships everywhere else, interviewing for a bunch of different things. And, through that entire 2.5 years, through the entire 503 applications, I got one offer. I got one internship offer, which was ultimately the internship that I ended up doing at Apple, which led to my full-time job. So again, super interesting experience there. And I think the thing for folks to keep in mind, and I get messages all the time on LinkedIn or Twitter, and someone's like, hey, I applied or 2 or 3 times and I didn't hear back. And I'm like, okay, well, I can acknowledge that you've done that, but those are, in my opinion, in my experience, those are sort of almost meaningless numbers. You're not going to apply 2 or 3 times unless you're the creme de la creme and the best software engineer ever and get a job right away. I think you have to put in that extensive amount of hard work over a long period of time. And when I say hard work, I mean in your actual, whatever the craft is, whether it's software engineering or what have you. But then you also have to spend a bunch of time applying for these different opportunities and continuing to do it over an extended period of time. If there's something that you want, it's not just going to happen in 2 or 3 applications for most people. It's going to take a long time. And I think if you don't quit, you can't lose. So that's what I loved about that experience. And I think, I got a bunch of interesting people applying and saying things when I tweeted this out, but it was again an important learning lesson for me. I think the other one that I tweeted out a while ago before that one was when I was in my undergraduate studies at De Anza. I actually, again, I was looking for an internship. I ended up emailing every single professor at Stanford who on the website said that they were doing research, and every single professor either said no thanks or didn't respond. And again, another one of those experiences where I put in a lot of time to reach out to all these folks and it didn't work out. But that's just, again, the reality of the journey. I think those pictures where it's like success, what people think success looks like, and it's like this very linear line of growth, and the reality is the other version of that is the case where you're sort of going all over the place and going through loops and circles and ultimately ending up at whatever that finish line is. But it's not a straight linear line. It takes a lot of time. It takes a lot of work. It takes a lot of applications for the most part. But again, if you don't quit, you can't lose in that sense. Yeah, and folks talking about being excited for JuliaCon. I think it's going to be awesome. It's going to be a ton of fun. So looking forward to seeing people there and hopefully connecting sort of in a more face-to-face environment through GatherTown. I think it's going to be a ton of fun. Other questions, thoughts, things that I can help out with? Otherwise, this has been great. I'm super glad there were some questions coming in and such.
So thank you so much, Logan, for this amazing session. It was great to learn about Julia programming language and looking forward to contribute and learn the language. So it was great to listen about your experiences as well at Apple, at NASA. It was great.
Yeah, happy to share. And again, hopefully folks found this beneficial. And if there's things that I can help out with sort of as you go through this journey, even if it's not, contributing to the Julia language, feel free to ping me, shoot me a message on Twitter, shoot me a message on LinkedIn. I'll do my best to get back in a timely fashion, but always happy to help. I think this is a super impactful journey that folks can go on. So if there's questions or hurdles or things like that, again, always happy to help out.
Yeah. So if anyone has any questions, you can put down in the comment section, or you can ping Logan, as he said, on Twitter and LinkedIn.
Yeah, I'm glad people found the session helpful. I think this was great, and if there's no other questions, I think we can wrap it up. And I'll say thanks to everybody at Hack the Mountains for putting this together. I think it's been great. And again, you all are doing the right things, going to sessions like this, being part of hackathons and workshops. Those are where you're going to learn a ton of things, and they're going to help in the long run. So congratulations to everyone for doing the right things, and thanks again for having me. I think this was great.
Yeah, thank you, Logan.
Yeah.